here we are now. We have two sessions more. Next session will be, and I see that Teresa and Eddie are already online, so thank you for that. And I'm looking forward to hear your vision on adopting edge AI in autonomous machines. So please share your screen and let us know about that.
You there, Teresa?
Yes, give me just 1 second. Hopefully you can see it now.
Yeah, I just need to be in. There you go. That's cool.
Perfect.
Thank you very much. Well, thanks, guys. And thanks to the Incense and Mavella guys for inviting us to this conference today. I've been following it along a little bit, so it's some great, interesting content there. So we're going to do this sort of in a two-step stage. You've got myself, Eddie Seymour, the Business Development Director here in Europe for the Jetson embedded business. And then you got Teresa, who's one of our solution architects, very much specialist in the robotics area, and Isaac. And she's going to do a little bit deep dive on some of our tools, our SDKs, and our software packs that really accelerate our platforms. If you go to the next slide, Teresa. It's just going, oh, it's quite slow, but there we go. So a little bit of background, which I'm going to cover on what we're doing, where we're going from an Nvidia point of view. And, you know, some of you guys will know this. But, you know, this is a picture of our new facilities in Santa Clara. We're a US-based headquarters company, but we have development all over the world. This is just our, you know, headquarters building, which is sort of the central focus and central funnel for all of our main development. But as you can see, AI has really come of age, and this has generated a whole new environment and developers, and really what we call the Da Vinci's of the world and the new Einsteins of the world in the world of AI. Nvidia is really pioneering that now and using what we leverage our GPUs in order to tackle some of those very complex challenges in AI. Next slide, Teresa. Jetson is our CEO. Here's a picture of him. You know, he's a great visionary. And I think we've really, you know, he's been driving the helm of Nvidia since its founding in 1993. You know, most of you guys know us as a graphics gaming company. That was our heritage, and we're very proud of that heritage. But of course, now people are able to leverage our technologies in all multitude and multiple facets of user cases, again, in the area of AI. And you're going to see now we are covering every area, including networking and in computing in general. But everything we do is about accelerated computing. So that is really the fundamental shift we see in processing now. Next slide, Teresa. And where we see this, I mean, we call ourselves a platform company. We're providing our technology to customers like yourself and partners like yourself in order to leverage our platforms in various areas. We talk about at the top level, you know, that could be gaming, high performance computing, healthcare, smart city, robots, and autonomous vehicles. And you know, we have a very focused teams who are very focused in those verticals to help accelerate those applications in that area. Below that, we have, of course, all of our tools and all of our SDKs, whether that be virtual GPU, whether that be things like Omniverse, which I'll touch on towards the end, things like Fleet Command in order to manage. And then we have our base hardwares, and that goes everything from Jetson all the way through to DGX from our computing platforms. And then underneath that is our chip architectures themselves. So, you know, we are a full stack, whether it be chips, systems, or algorithms, or applications. And, you know, basically, as we say, we're sort of an a la carte menu is for system integrators, for OEMs, for software developers. You can take as much or as little as you like of our platforms in order to build and design your systems or your products on the top of our architectures. So next slide, Teresa. And that's really proven. You know, we have over 2.5 million developers now We have also startup companies that are using our applications to accelerate, over 8,500 startup companies, and we use we have basically a team that we call Inception that allows our startups to get direct access to us. So it's a full ecosystem of software, universities, startups, and partners that are really servicing that great ecosystem of developers out there. Next slide, Teresa. And we're really not just a graphics chip company anymore. I mean, as you know, we have a whole wealth of architectures. We have our GPU, which is today's latest architecture, is Ampere. We have our DPU, which is our networking and data processing unit for the data center, which we call Bluefield. And soon we have our CPU architecture based on ARM technology, which we call the Grace. And so we really are a heterogeneous system. We are GPU, CPU, and data processing. And again, multifaceted, really focused at the data centers for AI. Next slide, Teresa. So a couple of showcases going into the robotics now, and we've seen a lot on AGVs, and we've seen a lot today and this morning on the types of devices out there. One of our partners, Oculus, based in Germany, has been using our Jetson platform really for the automotive business, for several of the big automotive manufacturers. And this is to re-engineer the manufacturing processes of the future. Today, we see manufacturing processes that tend to be fixed production lines, where the cars are traveling down and then workers are working on those cars. The new world, as consumers, we want different colored seats, different colors, different this, that, and the other dashboards. And that's made quite a model of where the car needs to be built up from scratch. So Oculus has really built this robotics engine to allow people to be able to customize those robots. We're going to run a video. We'll see how well it works, give you an idea of the sorts of things that are going on here. So these are the travelers. This has the Jetson in, and you can see the robots are moving around with the car on, and then the production workers, they could be like multifaceted features or environments to allow them to do this. High flexibility in that working area rather than having to invest in this fixed setup. So we're really bringing now Nvidia to the AI to the industry areas, and you've seen some of those already. And this is really the next chapter for enterprise. And we are engaging with all these robotics, not just at the edge, but as a total end-to-end solution. So data center all the way down to the edge. Next slide, Teresa. And the big party that's there, we talk about one of our platforms called Omniverse. This is really a virtualized meta factory of BMW is the big partner for us on here. This allows them to create a complete factory in a virtual world and be able to use those things and before they deploy out to the factory. So this is really what we see as the next level, and you've heard a lot of discussions on meta universes. And we are very prevalent in this space now in multiple areas, whether it be factory robotics, in healthcare, in order to bring that to fruition with our channels and partners. So I think now we're going to go into a deep dive with Teresa. If you want to go step to the next one, Teresa. Yeah, so just as a summary, Nvidia is a learning machine. We really want to work with you guys and help you constantly evolve and adapt for these new opportunities. With that in mind, now Teresa will get into a deep dive on some of the tools and things that you can download and get involved with. Over to you, Teresa.
Thanks, Eddie. Yeah, now that we've seen a little bit more of Nvidia as a full stack company, I'm just going to go a little bit deeper into our robotics platform. And just to give a little bit of context, and I think you're well familiar with a lot of these, but we see a lot of market growth in robotics, but there's also a lot of challenges when it comes to robotics development. First of all, of course, robots are quite expensive to build. It's usually a very time-consuming process, slow, can be quite risky as well. depending on the operational environment of these robots. As a second point, they can operate in a lot of different environments, and usually these are quite unstructured. There's a lot of dynamism, a lot of uncertainty. Specifically, if we talk about warehouses and factory floors, of course, there's a lot of moving pieces, and these environments change daily. And on a third point, we've talked a lot about sensors in this webinar already, a lot of sensors, computational, AI. And so robots are made of a lot of different complex systems and components. And so there's also the need of integrating all of this together and of course, having the right computation to allow for all of this. And so our motto, I would say at Nvidia, and Eddie was explaining a little bit on, it's really today when it comes to robotics, based on two main foundations, I would say. One is AI. So basically everything will become smarter, including the robots. And the other one is a lot on simulation and these virtual worlds and digital twins. And so the idea here is that anything that is built will have a digital twin. So if you can plan and prototype all of these things and test your robotics development even before they are built in a virtual scenario, that can, of course, give you a faster time to market. Anything that moves will be autonomous. Traditional warehouses, automations, and so on are very good at doing certain tasks. So when we talked about robotics, they are programmed to do these certain tasks, and they are very good at it. But in order for them to have a little bit increase the situational awareness and to have a little bit more versatile type of development, there's certain AI and challenges, and we need to have these robots becoming a little bit more intelligent. And on the last step, anything autonomous will be simulated. So in order to bring AI to robotics, you need to do a lot of training, and it's impractical to do all of this training in reality, of course. So AI agents can really achieve better intelligence by training in very scalable environments and also photorealistics that can obey the laws of physics. And so having this virtual world where we can generate all of this data to train your robots on, but also where we can test the applications of the robots, it's super important. And it can also allow you to test several corner cases and even unsafe scenarios that you would not be able to test in the real world. So this is a little bit of the context and why we have the NVIDIA robotics platform, which we call ISACs. It's really to help our customers and users to build more intelligent robots and to leverage a lot of our AI and hardware accelerating expertise. And so if we go a little bit over the robotics development phases, traditionally, of course, there's a lot on development, deployment, a little bit on simulation. But now with the new advance on AI, it becomes also very data-centric type of approaches. So there's a lot of different phases, I would say, involved in order to have this end-to-end type of solution. And so, of course, you need both real and synthetic data, as I've been talking about, to train your algorithms. You also need a simulation environment to test and develop on. Of course, your robotics development framework and also some deployment interfaces. And so at NVIDIA, we're really trying to connect all of these things together in order to allow for faster development as well, and to make robotics more robust. And so it's not, ISAC is not a single solution or a single SDK. It's really a combination of several building blocks that you can use all of them, you can use just pieces of it. Some of these are actually cross industries. So things like we see here on the training side, TAO Toolkit, it's a framework to help you build faster and better AI models. You have access to pre-trained models that you can then enhance with data, as an example, that you could generate in the synthetic world. And this is not just specific to robotics, as well as here you see DeepStream, which is our intelligent video analytics platform. So a lot of these is cross industries, I would say. There are, I would say, two that are very specific to robotics. One is Isaac Sim, which is the simulation platform, and Isaac ROS, which are ROS packages that Nvidia provides. And so I'll be focused a little bit more on this. But as you can see, it's a full end-to-end platform. And because of that, and because it's all based on our CUDA computing platform, it's also integrated with our different full stack type of chips, both on EGX data center cloud, possibly more on the simulation, developing training phases, but also on our family of powerful Jetson embedded devices for the brains of the robot. As a last piece, of course, to this platform, it's really important for us, it's also our ecosystem. And we partner with several different companies, a lot of you included, and when it comes to sensors, frameworks, robotics hardware and software solutions. And this is really key to our go-to-market strategy and also to help us scale our deployment of our solutions. And so going a little bit deeper into the simulation part of things, Eddie already talked a little bit about Omniverse. Omniverse is really our platform for creating and connecting these virtual worlds. And it's a collaborative platform and basically built from the ground up to leverage core Nvidia technologies like physics, AI, real-time ray tracing, and path tracing. It's also a collaborative platform in the sense that it can have collaboration between team members on the same projects and scenes, but also between tools. So it's not really a tool to replace any existing software out there, but really enhance the workflow. So you can connect to a lot of existing tools to create your worlds. On top of Omniverse, we have several different applications for different industries and use cases. And one of them is Isaac Sim, which is the one more tailored for robotics use cases. So as you can see here, there's a lot of different things that we offer with Isaac Sim. Of course, you can create your world model with all of the Omniverse ecosystem and platform, and also with other Omniverse applications. And then when it comes to robotics development, we offer several tools to help you basically build your robot and develop and test your robot. Of course, you need to import, so very common data formats like URDF, CAD, Onshape, ShapeNet are supported. Robots also have a big sensor suite, so you have access to sensor models, IMU, LiDAR, range sensor, camera, so on. And then we offer several utilities, map generation, navigation and manipulation type of examples, synthetic data generation, again, as one of the main focus to help you automatic label training data, both 2D and 3D. And also as a last point, of course, all of the robotics interface that will let you connect to your robotics development frameworks, either ROS, ROS2. Also, Omniverse is a very open platform, so you can develop your own custom integrations and customizations on top of it using our Python APIs. This is just a quick example. I don't know how smooth is the playing, but this is just showing an example of a multi-robot navigation, in this case in a hospital environment. So you have three, let's say, robot brains running ROS2, NAV2, and then connected to Isaac Sim to do this multi-robot simulation, which can be quite interesting, of course, not only to simulate a single robot, but also how they can interact with each other. And these are examples that we also offer out of the box with the platform. Another big topic, as I said, is the synthetic sensors. So let's say we've talked a lot about perception and situational awareness. A lot of the times you'll need a lot of data to train this object detection or image segmentation type of algorithms or LiDAR segmentation. And so with Omniverse and with Isaac Sim, you have access to all of this ground truth information that you can just use to build your data sets. And let's say here you could try to basically detect what is a rack, what is a box, and so on. You have access to all of this type of information. And just to a visualization example, here you can see the robot is navigating through an environment while we randomize it. And this can be quite important, not only for testing different scenarios, but mainly because perception can really perception algorithms really need a lot of training data in different lighting, materials, scenarios, and so by randomizing all of the environment, you can build much more robust data sets, and you can do it automatically and generate massive amounts of data like this. As one of the last points, of course, you can also connect our Isaac simulation to Isaac ROS. Isaac ROS is our initiative to bring our AI expertise and hardware acceleration to the ROS community. And so the main point is really to accelerate the hardware performance and also to scale with these AI algorithms. And so the idea here is that if you think about the robotics development, a lot of times developers are not necessarily experienced with hardware acceleration, right? So we offer ROS native packages for some perception workflows like April tags detection, image segmentation, pose estimation, visual odometry, and so on. And these are built to leverage all of our hardware accelerating libraries, so you don't really need to know how to program in CUDA to make use of this. And this can also be seamlessly integrated with your other packages, ROS packages, and tools. And one of other interesting points is, of course, this is hardware acceleration for ROS, but it also optimized to run with all our computing platform, either being Jetson or a GPU server, workstation or server, which I think, from my point of view, also makes it much easier to connect again all of those development and deployment and training and simulation phases when it comes to robotics development. So this was a little bit on what we have and more focusing on the robotics. I also wanted to talk a little bit about what's next and some of the things that are coming. We just recently announced this January, actually, our Isaac AMR platform. And so at Nvidia, we really recognize the increasing demand for AMRs. And so specifically in these logistics and warehouses environments. And so we're basically launching this AMR platform, which consists of several GPU accelerated AI technologies and SDKs. A lot of these are already available. So I've been talking about ROS Gems, Isaac Sim, Replicator is our synthetic data generation tools in Omniverse. Others are still coming and are basically now being announced, but are some of these things that we really believe can really help people who are developing robots in these environments. For instance, DeepMap is our cloud-based SDK. It's not there yet in terms of publicly availability, but it's something that we're definitely investing on. And this will basically help the mapping phases, right? So specifically in warehouses and factories, and all of these unstructured environments are completely changing all the time. So there's really need to rapidly map or remap these environments. And so we're leveraging DeepMap to basically help in these processes. Reopt is also super interesting. It's a platform that we recently announced in the last GTC conference. And this is really a platform to help routing optimizations. So if you think about the travel salesman kind of problems. And so, of course, you can adapt this to robotics as well and to AMR platforms. Let's say you have AGVs or AMRs that are picking material or some loads from A to B. And so you can real-time optimize the routes of these robots according to different constraints like battery speed, transport load, and so on. So this is Reopt on early access. It's also a super interesting platform that can help a little bit more on the fleet management side. And then we have another example is Metropolis. This is also a very robust platform already, used cross industries in our intelligent video analytics, but can really help as well to improve the situational awareness of these robots. Because, of course, you can put a lot of sensors in a robot, but you also have a limited field of view. So let's say if you have cameras spread around the warehouse, you can bring much more intelligence to this system as a whole and use our Metropolis platform. So this is just an idea of some of the things we are working on and that we believe as a future of the AMR platforms. All of these are built on Nvidia AI and also in Nvidia Omniverse. And this was just an announcement we made this January, so I also encourage you to go and check it out. All right, and just to finalize, this was not going too deep into the technical details of the platform, but I wanted to give you a good overview of what we are working on these days. And I also encourage you to check out our GTC conference. Next one will be in March. And we talked a lot about robots, a lot about digital twins, a lot about simulation, logistics, warehouses. So it's free to register. So I also encourage you to go and check out some of these AI advances in the field of robotics. And with that, I open to questions to either me or Eddie. And thank you so much for your attention.
Thank you, Teresa and Eddie. And to the questions that they just, but we did get some questions during your talk. So first of all, will Jetson focus on Linux kernel other than L4T?
So yeah, I'll take that one. So today we build the Jetson on L4T, which is what the partner has said there, or who has mentioned it. We have many other partners though that are developing distributions from that. So it could be Red Hat, could be other distributions. So ours is a baseline Linux for people to integrate. Some are actually doing customized versions. So we've just tried to make the L4T as open as possible as an open platform in order for other people to integrate.
All right, thank you. Next one is, are you also considering radar sensor models in your ISAC simulation?
Yep, I can take that one. Yeah, we have LiDAR, radar, ultrasonic sensors, a lot of different range sensors, IMUs, and so on. So yeah.
Okay. And the next question is one I might be able to answer as well, but does your Jetson also work / interface well with the Xsense IMUs?
Yes, you can answer that one.
Yeah, I know we have a ROS driver that is compatible with your Jetson as well. So
yeah, and I think we do have a lot of partnerships when it comes to drivers and driver sensors. So yeah.
And we basically actually have an article written about that. Anyway, based on which parameter or aspect can we say an image processing software is faster? How do we validate the faster response from camera system?
I think that's a very good point. I think there's different types of performance involved. One of the things that usually you hear a lot is probably around images, as the FPSs of the cameras and things like that. When it comes to AI, it's a lot about the number of inference that you can have per second. So let's say the number of, when you have the AI model, of course, let's say you need to detect an object, and how fast can you do that? Let's say how many object detection can you do per second? It can also be how many of these you can do in parallel, right? Because a lot of the times you don't have only one camera, but you have multiple cameras that you want to run inference on. So I would say it's a lot about how fast can these processing, image processing algorithms or AI algorithms can run on this sort of software and hardware tools.
Okay, one final question, I think that is, which sensors are supported by your Jetson?
I think just, I think the best thing would be, we have our developer site, which contains everything. There is a forum, so you can share information about what you're doing on Jetson. Plus, all of our partners are on there, all of our sensors, cameras, partnerships are all on the developer side. It's extensive, let me put it that way. So more than we could probably put on this thing, but I would encourage anybody to go to the Jetson developer pages, and you will see all of the guys that have been tested and proven on the platform.
All right, that sounds good. Well, one more question came in, so if it's okay, I just want to ask it. How much of performance improvement can we expect from Isaac ROS? Is Isaac ROS already publicly available?
Yes, I don't have the performance numbers on top of my head. We do have some performance numbers that I can try to point you to if we have the email of the person who asked the question. I think we do have a couple. We have some benchmarks, and we definitely saw quite a few performance improvements. Isaac ROS is already publicly available, and it's open source on GitHub. And so basically, Isaac ROS is a couple of ROS packages for certain tasks, let's put it like that. And we are releasing more as we go. Of course, this first one, we have things for visual odometry, image segmentation, April tags detection, and things like that. But we're also releasing more, and we are very open to hear what are the needs of the industry as well. So if you have ideas and thoughts about what can really be helpful for you to accelerate your robotics development, we are more than happy to hear that. In terms of performance, I'll reach back to you with the exact numbers, but we have seen quite a few improvements.
Yeah, we'll share the email address, and then you can pick that up. Well, thank you, Teresa and Eddie. It was a good presentation. Nice to get your insights on it, and thanks for answering all the questions as well.
Thank you.
Thanks, guys.
Have a good continued conference. Thanks a lot.
Yeah.
Bye.
Thank you.